Now let's take a look at a linear log question from Chung. The table shows to one decimal place the mass m of a radioactive substance in grams after t days. On the grid opposite, plot ln m against t and draw a straight line graph. Now we have the question asking us to plot ln m. So we're going to first draw a new table over here. So let me type my calculator. We're going to take the values highlighted in blue, do a ln 57.7 and put the answer there under t equals to 5. Click calculator for this value here. I'll be getting 4.06. And I continue doing for the rest of them. We type ln 37, ln 23.7 and so on. So I have all my answer here. I've gotten all my values here. So we're going to plot this into the graph. So you need to notice that whatever they've given you here, plot ln m means this one you plot on the capital y-axis and capital x-axis is going to be t. And let's go to our graph. This is our graph here. Remember to extend your line to cut the vertical axis and remember to label the axis here, ln m versus t. Okay, so this label over here is important. Do not label y and x. Now let's take a look at the question again. Part B, we need to find the gradient of the straight line and hence express m in the form of m naught e power of kt. Now I'm going to use the value here. Of course, you can read the graph to calculate the gradient. And I have already gotten the capital y-intercept, or we call it the vertical intercept in the graph, which is 4.5. Let's write down the information here. So I'm going to write gradient equals to, I'm going to calculate 2.27 minus 4.06 divided by 25 minus 5. So this answer here, I'll be getting a negative 0.0895. So this is part B. And for C, which is the vertical intercept from the graph, I'm going to write down 4.5. Now, what we're going to make use of is this capital Y equals to mx plus c. And I'm going to replace capital Y with the label, which is ln m. Now, do not confuse this m and this m. So this and this, they are not the same. Okay, so this m represents gradient. If not, then do not write this label here. So it's going to seems a bit confusing. So I'm just writing this to help you understand. This m is this m. This is a gradient m. Okay, so this m is mass in the question. They are not related. So this value here, I'm going to replace here. I will be having minus 0.0895 and capital X is this label here, which is t. So C value is the vertical intercept, so I write plus 4.5. Okay, so another option to reduce confusion is that maybe you can use a capital M instead for this value over here. Okay, so that you know that they are different. This is small letter m, this capital M stands for your gradient. So next step here, what we need is m, not ln m in the question. Let me just flip back to the question. We need to express m, so not ln m. So what we're going to do is take e, both sides. So what happened here on the right hand side, this e will raise to the power of 0.0895t plus 4.5. But they are asking for the form of m naught e raised to the power of kt only. Kt only means they do not have this addition sign at the power for e. So what we're going to do next step, we're going to split it to e raised to negative 0.0895t. And we split the power now, so e raised to the power of 4.5. Okay, so this one here, you can type calculator. So what I'm getting is 90.0, and I'm going to write this at the back. So e negative 0.0895t. Now that you can see, I'm writing it in this form where this 90.0 is the m naught and this value here is the k value. But they only need me to write in this form. I do not have to give the answer for m naught and k. They did not ask for that. So that's all for part B for this question over here. Let me erase a bit to discuss part C of this question. Let's look at part C of this question here. The half-life of a radioactive substance is the length of the time it takes for half of the substance to decay. In order to determine the half-life of the radioactive substance, a suitable straight line can be drawn on the same set of axes as your graph. Find the equation of this line and hence determine the half-life of the radioactive substance. Now I know there are a lot of words and you don't know what half-life is. Let's take a look at how to do this question. Now let's take a look at our graph first. Remember that although we have the 4.5 there, the label is ln m, so that's not the mass, okay? So you need to be careful about that. Do not take halfway of your graph for this type of question here. So what you can do is that we have this from the previous part, the mass equals to, so what you can do is I have a time here, so we can find the initial mass by doing T equals to 0 and calculate what m is. So I'm going to take 90.0 E. This one I multiply by 0, so I get 0 here. So 90 times e power 0, that's going to be 90. So this is my initial mass when time is equals to 0. Now, what they ask you to do is that to find out the half-life, which is the length of time, means T equals to question mark. Okay? So this mass, I'm going to halve this 90. What I get is 45. Now, you need to be careful. I can't read 45 because this label is m. My graph label just now was ln m. So I need to take one step. Next one, I take ln m. So let's find out what's ln 45. By clicking my calculator, I'll get answer 3.81. So the equation of the line that I'll be adding, let me tell you about this one here. Do not label y equals to 3.81. Label follow the graph. So the graph label, let me just go to the graph now, is ln m. So what we're going to add is ln m equals 3.81. I'm going to add it to the graph and show you now. Now what you're going to do is that you add the line in your graph at ln m equals to 3.81, which is a horizontal line over there. And read the value from the point of intersection, read downwards. Let's read the value over there. So I'll be getting 7.75. And one more reminder, always check the axis is t, okay? So I'm going to write down here from graph. After I add this line, I can read t equals to 7.75 days. Okay, so this is the half-life of this question over here. Okay, so that's all for this question of linear law.